Hi everyone, I'm Dmitry from Envio, and a few days ago Fuel launched their mainnet, and if you're not excited about this, you probably should be because it's super cool. And this video is a video tutorial where I'm going to show you how you can build things on Fuel. So here we are going to create a simple smart contract for like just liquidity pool. I will use it as an example, but I think you'll be able to use it as a reference for any other contract you want to create, or like the app or anything like this. Then we'll take this contract and deploy it on Testnet, so you can see how like wallets work, like deployments. Also, I'll show you Block Explorer and how it's different from normal EVM chains. Also, after this, I think it's not interesting to stop just deploying the smart contract. We want to actually use the data from the blockchain to build an actual application which our users will be able to interact with. So here we will use Envio, the tool we are building with our amazing team, to create a backend for this smart contract, and then we will deploy it on our hosted service, and you'll see how easy it is. And as a result, we'll get a smart contract deployed on a testnet and a backend running and ready for you to use it for development your amazing web applications or like any other application. So at the end, we will have a GraphQL endpoint with ability to get all the blockchain data of your from your contract. So let's start with a brief explanation what's Fuel and why it's amazing, and then we will continue with actual development. So let's start with a brief introduction of Fuel. First of all, it's a new network, but actually it's much more than this. And because it's a completely new virtual machine, it's not EVM, but still it's compatible. Also, it's a new programming language called Sway, which is similar to Rust. And yeah, you can't build smart contracts on Solidity. You need to use Sway, but it's not a bad thing, in my opinion. Also, it's a completely new design, like how the smart contract is executed and how the data is stored on-chain and off-chain. And yeah, it leads to many amazing benefits as security, performance, like fees, like it's super cheap. And like I think this shows on the website pretty well what Fuel is. Like it's parallel, really optimized state. There is native abstraction for accounts, native assets, and also it's like have quite fast execution, small fees, and also like really good compatibility as Ethereum. So it's pretty nice. You can check all the info on Fuel.network. Also there is proof like validation from really big names like Vitalik. So it's a thing you should take a look at definitely. And also there is already an existing ecosystem you can find at clicking try apps. So there are already running applications, and I think it's a good time to build even more things, because this is quite a green field currently. So, and you can see that my internet is quite slow and images are not loading, but there are quite many of them. And many of them are using Envio, which we'll use in the tutorial. So you will be able to build an application and have it listed here as well. So let's go to the code, because I think this part is getting boring. When we're working with a new tool, the first thing I recommend everyone to do is to check the documentation, and you can find it from the main page by clicking developers and documentation here. So I really recommend you to read at least main pages here, but to follow with this tutorial, what we actually need is to open the quick start, and here are like 3 different guides, and we are currently smart contract developers, so we need to open the first one. And here it comes with some installation prerequisites. It shows how to install Fuel app, which is a version management of the whole tool chain, which comes with other like tools like Fork, which is a build system for Sway programming language. Also, for this tutorial, you'll require to have Node version installed, Git installed, pnpm, npm. Well, I think npm is not needed, only pnpm. So all this Node.js stuff, we'll need it later for the backend development. But for the part with the smart contract, you only need to follow this guide. Also, below there are some more tutorials how to actually set up a project and build a simple contract. I also recommend you to read this, but we are going to do this ourselves in a few moments. So the first thing I prefer to do when I start a new project, I actually create a GitHub repository. I've already done this on the background a few minutes ago. So what we can do, we can clone the repository and open a terminal. So yes, let's clone it here. And why I prefer this, so we can have a version control from the beginning, and we can keep track on the changes and not lose anything by mistake. So after the project is cloned, we can open it in our favorite editor. So yes, we are trust the author, and let me tweak some windows so you can see it in a good way. Okay, I moved the window and made it a little bit bigger. So we have an empty project here, and let's actually open terminal and follow the tutorial we just checked. So we want to create a new smart contract, and here I don't want to do it in the root repository because I also want to add a backend in this GitHub repository, and maybe we'll have other contracts in the future. So let's create a directory called contracts and open it here. So, and what we are actually planning to do, I'll want to repeat one more time. We are going to build a simple liquidity pool contract where users will be able to deposit a base asset, get liquidity pool tokens back, and then they will be able to withdraw all the deposits they have by sending the liquidity pool tokens to the contract. So it's kind of just no additional logic. Deposit the base token and withdraw it back. And when I say base token, it's a term in Fuel. Base token is Ethereum in this case. So Fuel also uses Ethereum, which is nice. So we are going to deposit Ethereum and get some asset back in exchange. So here we have contracts directory, and in it we can run fork new and name of our contract. Let's call it Sway LP. Okay, let's call it just pool. I want to call it pool. And what it says, I think it succeeded. Yes. So we if we open the files which were just generated, we can see that there is a fork.toml. For the ones familiar with Rust, it's something like packet, like you know what it is. And for people coming from the JavaScript ecosystem, it's similar to package.json. So no dependencies here, just a simple project, git ignore with some basic files and our main file. .sv, it's a file extension for Sway. You can find a Sway VS Code extension here, and I recommend you to install it, so you'll be able to get this nice syntax highlighting and autocomplete, which won't work without the VS Code extension. So if you take a look at this smart contract, it's quite simple. The first line says that it's a contract because there are different kinds of entities you can have in Fuel. Like, for example, there might be predicates, which are pretty interesting. I recommend you to read about them in the documentation because we are not going to touch them in the tutorial. As next lines, we describe the interface of our contract, which says that it should have a test function and it returns bool. This is a Rust syntax, and if you find it scary, a really interesting tip for you, I can say, like if you have some problems with the Sway syntax, what I recommend you to do is go to ChatGPT and say, hey, how I can do this in Rust? And in most cases, it will work because Sway is based on Rust, but actually it's not 100% Rust because it's fine-tuned to better serve the blockchain development. So the suggestions won't work in 100%, but for some simple use cases, it might be actually working. So if you struggle with this, this is a tip for you how you can improve the suggestions from ChatGPT, because ChatGPT doesn't know about Sway yet. So after we've described ABI, we actually implement this for our contract, and our contract might have multiple ABIs, so we can have my contract 2 ABI, and it can also be implemented here. So just in case for you to know. Yeah, and implementation says that our test function, it just simply returns true. So that's nice, and let's start with building our liquidity pool. And to save your time from seeing how I sweat trying to remember and find the Sway API in the documentation and like type everything here, I've decided to write the contract on the background. So what I'm going to do now is select everything and paste. So this is all the contract, 60 lines, not much. And instead of doing it and writing it live, I'll just suggest to walk through what's written here. The first thing is ABI. It's the first thing to check because it gives us understanding what's going on here. We can even do this without reading the logic. Of course, reading the logic is important. So two methods, deposit and withdraw, the same as it kind of matches to the logic I've described. So deposit, what it does, it accepts a recipient, like which address should receive liquidity pool tokens. So we send base asset from our account, but it's not necessarily that we should receive a liquidity pool token. Like anyone can receive, which was sent in the recipient argument. And identity here is a type which combines both wallet addresses and contract addresses. So it's not necessarily that liquidity pool asset might be received by a user. It might be also received by another contract. A new thing which might be confusing and what's needed to mention is this payable attribute. And what it does, it says that this method should, it can't have an asset attached to it. So if there is no this payable attribute and user tries to send a transaction and attaches some assets to the transaction, it will fail. So it kind of validation from the execution time and like from the usage side, and also inside of the deposit we won't be able to access assets attached to the transaction without this payable attribute. And how it looks like in the implementation here, we can get the asset ID of the attached token, and we can also get the amount of the attached token thanks to this payable attribute. So going back to the ABI, we also have the withdraw, and withdraw also accepts recipient, like who is going to receive back the money they deposited. And let's read the logic a little bit in more details. But before I do this, I want to show you that when we use some functions to get amount attached to the transaction or asset ID, we need to import them from the standard lib here. There can also be other packages and libraries, but here it's also similar to the Rust module system, like it's the same. So if you don't understand what's going on, you can read about this in the Rust docs or in the Sway docs. But in a nutshell, we import some standard library. Inside of the standard library, we import the package to work with assets, package to work with bytes, and some packages to get constants and message mount. So let's check where they are used, and going to the deposit function, which is the most interesting here. What we do first, we check. We do a check. First of all, we do a check. There are two ways how to do checks. First one is required, and I actually prefer this because it allows you to add a message which might be useful for debugging and figuring out what went wrong. The other one is to simply call assert. There is no additional message sent together with the error, which is like difficult. Will make things difficult to debug when you have multiple assertions to figure out what went wrong. And okay, the first check we for the transaction to and for the function to run, we want to check that the asset which was sent to the together with the transaction is a base asset. And what base asset means, it's Ethereum. So base asset, if we go to the definition, which doesn't work for some reason, let me try to reload the window. Yeah, so now it works. So base asset, it's difficult to say what's going on here, so I wanted to see the ID. But what it says in the description, that base asset is Ether, and that means that for the function we expect a user to attach some Ethereum to make it work. Also, as next line, we check that there is at least something, like some amount of Ethereum sent together with the transaction. So if it's less than 0, it doesn't make sense to work. And after we verified that the amount is Ethereum, we can safely mint some native assets, which will work as liquidity pool tokens for us. So to do this, we call this mint2 function. After I hover it have quite detailed information. But let's go to the definition, and we can see that in a nutshell what it does, it calls mint and then it calls transfer. So we mint some tokens with this amount, and what the sub ID here is kind of an an identifier of a native asset. Native asset, it's an asset which belongs to a contract. So a contract might have multiple native assets, and they are identified by this sub-ID, and sub-ID is the P256. So it's a really huge number of assets you might have for a single contract. But in our case, our contract is going to have only one asset, which is a liquidity pool token. And for this, to identify, so we are going to use this zero constant to as sub-ID identifier, because zero it's the first in programming. That's the reasoning. So what we do here, we mint our liquidity pool token, and then we transfer it to the recipient. And to transfer something, you can see that, I just started using only my right hand and had problem with going to a definition. So to transfer, you can see that transfer accepts asset ID, it doesn't accept sub ID. And what is asset ID? Actually, asset ID is a combination of the contract address and the sub ID of the asset belonging to the contract. And to get the contract ID of the actual running contract, we can use this function, and sub ID we already know beforehand. So we join them together using this asset ID new function. And actually, you don't need to know this and simply use min2, which is provided in the standard library. But I think for better understanding what a sub ID and asset ID and how it's created, it's good. And below, we do a log. We actually don't need to do this, but I just wanted to show you how logging of events logs in Sway, and it's actually amazing because it's super powerful. You can log whatever you want here. You log a deposit event struct, which we described a little bit above, and it contains of recipient and amount of tokens which were deposited. So we create a struct and log it, but actually you can log whatever you want. You can log numbers, you can log strings, so anything you want here. For those who are familiar with EVM, you know that you need to specifically declare an event, and then you need to write emit, and you can only emit the event which was declared beforehand. And also it's quite tricky that you can have some topics indexed and not indexed. You can put whatever data structure you want in the event. Here in Sway it's much more flexible. You can literally have nested structs, enums, so it's a really powerful tool. And yes, so if you want to build some indexer, I definitely recommend you to create this structs. Usually the indexers we've built and the indexers other people who build indexers using our Envio tool, we add this event suffix for a struct, so we know that it's not used for the smart contract logic, it's used for logging in events. So just in some place you declare all the events you want to log, and then you log them and populate with some data. Of course, we support also indexing the mint, burn, transfer call, but with logs you have much better control, because you can structure, put the fields you actually need. So for example, receipt and amount, you can either have it as a log, or otherwise you need to index both mint and transfer separately, which is not super convenient. So okay, let's go further. And the second method we'll take a look is withdraw, which is really similar to the boss, it's just the opposite logic. Get recipient who will transfer the withdrawn money, and it checks that we attached the liquidity pool token with the transaction. Also, next we get amount, checks that it's more than 0, and then we transfer the base asset Ethereum to the recipient we provided in a transaction, and we send the exact amount of liquidity pool tokens transferred together with the transaction. And then just to keep our balance balanced, we burn our liquidity pool token so it's not left on the contract account. So here's a really simple sweep program. And next I'm going to show you a script, how we can deploy this on Testnet for testing. But before we do this, let's first of all merge our changes to the GitHub. Let's write commit message create OP contract and push it. I prefer to use VS Code UI, it's simple. Yeah, after we have our changes on Git and contract written, so everything is nice, it means that we can start with the deploy itself. And for this, we need to build our contract. And let's open the contracts pool. So it's our contract directory. And to build, we need to use fork, the same as for installing dependencies and initializing a template. It's like used for everything, pretty convenient. So, and to build, we need to write for build. That's all. It's quite fast. And after we ran the build command, here we can see the output directory appeared, and inside of it there is debug folder. If we want to have a production build, we can also add release flag after the fork build, and then in the out directory you can see there are both debug and release. I actually done deploys with both debug and release binary. I don't know whether there are differences in binaries. At least the API is the same. But just in case, let's use the release. Also, what's interesting is the API. It's different from the EVM APIs, but it's pretty much the same. It contains all the types used in our contract. Also, there are functions which it has, like deposit, also withdraw, all the arguments and return values it accepts, also attributes that it's payable. And here we also have log types. And the first one, I don't know what it is, probably coming from standard library, just always exists here. And the second one is for our where is this log deposit event. And here you can see that it's not really that obvious. Here's some number, and this number is some sort of seek hash for the specific log. So for EVM it would be a token 0, but here there are no tokens, there are just this log ID. And if we, for example, if somebody else creates a log with the same deposit event struct containing the same fields and the same field types, they will have exactly the same log ID. So if you build some sort of tool, be aware of this, that you can't realize that this log ID belongs only to your contract. You can also receive logs from other contracts. So that's it. We've built our contract, and now also behind the scenes created a simple script to deploy our contract and do some mock interactions. So we can use them for taking a look at the Explorer and also building backend and using them for testing. So let's try to paste what I have. Yeah, here it is, the interaction tools. And just for better LSP work, let's go directly here. So here is interactions tools. Open it a little bit bigger, and here is cargo.toml file. I think it makes sense to start it. It's like a root of everything, and you might find some similarities like fork.toml, cargo.toml, very similar, because fork is a build system for Sway, cargo is a build system for Rust. Here I have a few dependencies. .env is to read .env file. I have a mnemonic phrase stored there. It's needed to unlock the wallet so we can interact with testnet. Also, I've added some environment variables to configure whether we want to be on testnet or mainnet if we want to later use a script for mainnet as well, which is a nice addition. Next is the fuels. It's SDK for fuel. And the naming was based on ethers, like ether and S at the end, and there's fuel S at the end. Rand is package for like work with random things in Rust, and I needed to create salt when we deploy a contract, like build and deploy, because otherwise, if we don't have it and we want to run the script twice without any changes in the actual contract, it will complain that this contract is already deployed. Why do you want to do this again? So I provide a random salt every time when I deploy a contract, so we can run the script multiple times. And Tokyo is a library to work with asynchronous code in Rust. So let's take a look at how everything works itself. So here is the env example. You can see that I didn't enter mnemonic phrase here because I don't want to show it to anyone, and believe me, you also don't want to show it, even though it's testnet. Still don't want to show. And here is the provider URL. We want testnet, but you can also enter mainnet and also base asset address, which is for Ethereum, and on mainnet and testnet they're different, so I also moved it to the environment variable. And also here, the most important, the single main file. Let's hide the left panel. And don't worry that there are a lot of code, and don't try to rewrite it like to your IDE when I explain things. I'll leave the link to the repository in the description, so you can just simply open it and read through. Also, some code was inspired by the full documentation, so also definitely recommend to check it out. And let's go quickly walk through the file. The first few lines are imports, not really interesting. And here, let's skip this part for now. Main is the beginning of every program, almost everywhere, besides JavaScript. So first line, we load environment variables so we can get the values from the .env files. Then we create a provider is to say from which network we want to get our wallet, and here the provider URL is coming from environment variables I just shown, and this is a testnet in our case. Then we want to have an unlocked wallet so we can perform transactions on our contract and also be able to deploy it. We need to pay some gas for this, so we unlock a wallet, use like real, like this is my personal wallet. So we pass a mnemonic phrase here, but this is not really necessary. I just used it for because it was like close to my hands. You can also use a private key. Also, you can pass an additional paths to the wallet. So if you have multiple like sub wallets or something like this, and so we get an unlocked wallet for with our phrase from environment variables and also with our testnet provider. So here's the wallet we can use later for all the interactions. Also, we get a complete asset ID from our base asset address string. And yeah, before doing the interactions, I just came across a few times that they failed because with some ugly error. So I just check, I get the balance of Ethereum base asset and check that I have at least 500,000. And if I don't, I print an error in the terminal and conveniently attach a link to faucet so we can get some Ethereum for testing. Super nice. Here is this salt generation I was talking before. Yes, this is needed to be able to deploy this contract multiple times whenever, like how many times we want. So here we load the contract from the binary we got after running fork build dash release. Otherwise we could use debug. This also works, but as I said, I don't know the consequences. And we deploy it with our wallet. So now we can get, after it's done, a contract ID and receive hashes, like an address of the contract. So print it in the terminal so we can later use it for our needs. And here's the pool module we are using to create an instance of our contract. And where this pool module coming from is from the lines in the beginning of the file I skipped initially. And this is a Rust macro, so this code doesn't exist now. This code is generated when we compile the program, and what it generates a module called pool we provided here, and it uses the ABI with this path to read the ABI and use it to generate a type safe, exhaustive module pool, and then we can use this module as in our code to interact with the instances of the contract. So here below we create such an instance using the actual contract ID we just deployed, and also passing a wallet which will use which will pay gas from when we perform some transactions. And we want to perform some transactions because we want to use them for testing, and also I want to show you how transaction in Swale and in Fuel looks like under the hood. So we create an instance and we don't need anything else besides methods, so we just get the methods here directly and then we work only with them. So here's this bunch of code. Looks a little bit scary, but this is scary because this is payable, it has a payable attribute, if you remember, which allows us to attach some assets together with the transaction. And to attach an asset, all this code is pretty much needed. So if we didn't need to attach an asset, we would be able to call the method just without all these lines. But since we need to attach some Ethereum to the deposit so we can get the liquidity pool token back, what we do, we first of all build the deposit method. And yeah, we call deposit. We say that we want to get liquidity pool token, as if you remember. All this, it's a recipient address, so we want to receive the liquidity pool token back to our wallet, which we use to send the transaction. And then in call params, we attach that we want to have attached Ethereum with the deposit amount. And this is 100 here. And also we say that we expect an output B1, which is a succeeded transaction. And so until this point, we've built like a method description what we want to do, and after calling call, it's actually called. So until we call, it's not called, but here, after I called it, we can await a response, and I deposit, and after I succeeded, I print in the terminal some message so we can know that it's done, and also I attach a transaction ID here so we can also use it in a block explorer and see how it works. So for withdraw, this is pretty much the same. I just decided to do one additional thing, is instead of withdrawing a hard-coded amount of liquidity pool tokens, instead we get our wallet and we get the balance of liquidity pool tokens. So we get all the the number of liquidity pool tokens belonging to our account, and we just say withdraw all of them. And to do this, remember, to get an asset ID, we need to merge contract ID and sub ID, which is 0 here. It's pretty much the same what we did in Sve. Now we do this in Rust. And after we get the balance, we can provide it to the call params for the withdraw transaction. And here we say that we want to attach liquidity pool token asset ID, and also we want to provide all the liquidity pool tokens amount we have on our wallet at this point of time. So after the transaction is done, we expect it to withdraw 100 Ethereum, to get 100 Ethereum back to our wallet account. So, and at the end, we print that everything is done, and just for curiosity, I'll log the contract ID here to show how it looks, not the address, but the contract ID. And I want to do one more change here, is copy paste this deposit block. Don't want to really move to reusable function, just copy paste. And we will call it one more time, so we can have some Ethereum balance on the liquidity pool token contract, and just to not leave it completely empty. So, and to run this, let's open a terminal, and here we need to write cargo run, and now it will compile all the dependencies and sub-dependencies, and I hope we'll see it succeed. And it succeeded. You can see that it taken 32 seconds, not super fast. So here in the logs you can see contract address, nice, that we deposited 100, then withdrawn 100, so the get balance logic works, and then we deposited 100 more, so liquidity pool contract doesn't stay empty-handed. And then at the end we log the contract ID, and you can see that it's a little bit different from the contract address, so we need to write contract ID.hash to get the contract address. And what we can do with all of this, let's open a browser and see at the transactions in the Explorer. And after, I think it's already 30 minutes, we are back on the Fuel website. So here we again go to developers tab, and we need a block explorer here. Let's open it. And after the page loads with my slow internet, we can see a block explorer. So let's paste our address here and hope that it will load. Okay, it's loaded. Actually, it took something like a minute. I hope it will improve. So let's paste the address and see what's going on. Well, it looks like an account. Okay, so we can switch from the mainnet to testnet, and I think here we should actually see the contract. So let's open it, and here we can find that there are some minted assets. Also, we can see that on our contract account there are some Ethereum. I don't know, it's either one way, I think it's 100 way, and also some transactions. And transactions are actually interesting because, like, let's take a look what we have here. The first one is contract creation. Let's skip, and also there are three other transactions. The first is deposit, withdraw, and the second deposit. And I think what's interesting is how they are structured, because instead of simple events or something like this, there are operations inside of a transaction. And also, if you read documentation, you might find another name for this. They're called receipts. So these are actually transaction receipts. And we can see in details how, like, what happened in the transaction. So we minted 100 of liquidity pool tokens, and we transferred it out to this wallet. Then we logged something and return. And actually, these receipts can be queried from the node, and you can use them. So inside of them, they're like it's like a JSON object with contract ID, sub ID. This file is amount. Also, for the transfer out, we can see an amount where we transferred this. But one thing to note, if you transfer to a contract address, this field will be called to instead of to address. It's just one tricky moment for you to know. And also in the log data, which is the most interesting one and which is used by the most indexers, we have this SIG hash or something like topic 0 or RB or log ID. I think log ID should be the official name in the Fuel ecosystem. Log ID, also the contract address where this which was called, and here we have the data. So this looks not readable, but we can use the Fuel's SDK. It's either Rust or TypeScript. Maybe there are for other languages as well. And we can get the API, get this log ID, get this data, put it to Fuel's SDK, and it will return us a decoded object. So this is pretty much how it looks under the hood. And we've taken a look at the deployed contract. It's on testnet, it works. So now we want to somehow provide a more convenient interface. So for example, we want to have a website saying that this liquidity pool have a balance of like 300 Ethereum, I don't know, something like this. So, and how would you do this? So first of all, you need a website, but we skip this because like website is like one of the ways how to consume the data. You might have a web app or something like this, so it's not a part of the tutorial. We here are going to build a backend for this. And the simplest way, for example, if we take a look at the use case where we want to show a balance of the liquidity pool in Ethereum, we can simply take a full SDK and just get the address of our contract and get the balance of the contract account. So this is pretty simple. But here are some downsides. Like the first one, it requires to actually call the actual node. Second one is it's quite limited. So we can, for example, in this case, we are working with assets, so we can get the asset and the balance of the asset. Also, for example, if we had a different contract, we would probably would be able to provide some read methods for the contract to read the storage data, but it's not really flexible because we like rely on like the round trip to go to node and return the data. That's not super reliable in terms of availability of the data and also the response time. Also, another problem that this data is like assets or storage data specifically is more designed in the blockchain to be cheap to store, and it's not really structured well for the reading. So and like it's not possible to like do some data aggregation or like for example, it's not possible to query like all the history of the balance change from the node. Like you, otherwise you need to like do either multiple queries and aggregate this all on the front end, which also have some downsides, like because if you do multiple requests, it's like more points of failure. Also, the data might be inconsistent because it's not like get in one transaction or something like this. Also, like yeah, I think this is enough for now, and just like the final point here is just you are not able to get all the possible data you would theoretically be able to get by indexing logs. So for example, in your contract, let's take a look actually at the transaction. Here, when the contract runs, we can log the data, and in this case we logged, as I remember, the recipient and the amount. So we kind of theoretically could get it from the transfer out event, but it's like not the most detailed. So for your contract, you can put however like really many logs with all the data, or even more detailed, like get some data from storage and log this, and then you can use these logs like to traverse all the logs belonging to your contract, aggregate them in some data, store in the data, and then you can query the database which is close to your users. For example, it's deployed in the data near them to get like to have some GraphQL queries to get this data immediately. So it's like will be just a few milliseconds latency, which is nice. Like, and this is what we are going to do this. And even though this sounds scary, this is actually not. It's super easy because there are tools available for this. And yes, without these tools, it would be really difficult because it's possible. Fuel provides a GraphQL endpoint where you can query a full node. Like they provide this for Testnet and mainnet. It's rate limited, but still. Also, you can set up your own node without rate limiting, and you can start querying all the blocks. And for every block, you can get all the transactions, and for every transaction, you can get every receipt. And you can filter only receipts belonging to your contract, and then you can find receipts you need, for example, log data, decode it using the full SDK. So it's quite a tricky process, and we are going to do this in a much simpler way. So for this, I'm going to use Envio. This is a tool that we developed, so I'm biased, but trust me, this is really good. And so let's start. We are back on the project. Let's open the root directory here. And what we need to do is simply start by running pnpx envio init. You can also use npx, but I like pnpx more, it's more predictable. Or also you can install envio globally and use Envio in it, but actually I don't like installing tools globally. So it's better to install it once and forget about this. So I think it shouldn't take super long. Yeah, it's written in Rust, so we install some Rust binary. Rust is a good language. You've probably noticed that I like it. And yeah, here it is. So which folder do we want? Let's go to the backend name, because what it is, it's actually a backend for us. So I think it makes sense to put an indexer in the backend folder. And we have an option of 3 different languages. JavaScript is like the king. TypeScript, the most popular one, so we'll stick with this, and this is the safest option with autocomplete and stuff. And TypeScript is really good, but it's very niche. So I choose TypeScript here. Fuel is the obvious choice, the next question. And how we want to initialize our indexer. Let's choose contract import, because this is the fastest way to create the backend for your contract. So what's the path to your JSON API? It is contracts, pool, and as you remember, we had it in the out. Let's use the release one, and here we can get the API. Nice, and it automatically parses the API, suggesting us some events we can use. And you can see this weird str log. This is the one which I said always exists in the API. And but also besides this, we have the deposit event log, and we can also index the transfer events, which like this is gets all the events when, I mean receipts, when we send some assets from our contract either to a user wallet or to another contract. Mint, burn, and also we can index calls, but it's more advanced. So let's say we want to build, as I said before, a UI for liquidity pool, and we want to display the balance. But the balance case is not very interesting, because I think it's an overkill for an indexer. And even though I like you to try it out and start building with Envio, I think for some things it's definitely better to read the contract data directly. So let's also make it a little bit more fun and start storing the historical changes of the liquidity pool. So every time a balance of liquidity pool changes, we'll create an entity in the database. So later we'll be able to, for example, get all these entities and create a graph, a timeline graph showing how balance changed with time. So it's like, for example, it increased, decreased, and something like this. So, and for this, I think it's a good use case for the indexer. I probably won't use all best practices. Mostly I just show what you can do with an indexer, but you'll see that without an indexer, we wouldn't be able to implement this in a good way by simply calling a contract. So I think it's a good example. And for the balance, what we need, we can track a balance in 2 ways. First one, we can track the balance by Ethereum on our account, or we can track how many liquidity pool tokens are minted. And I think for balance makes sense to track Ethereum. And for this, we only need deposit event, because when deposit event is triggered, we can track the increase of the Ethereum amount on our liquidity pool. And also we can track the transfer. It's when we transfer the Ethereum back to the user, so we can get when it decreased. And other ones we don't need. If you wanted to track liquidity pool, the minted liquidity pool tokens, because like in my implementation it's like matches one-to-one the Ethereum balance, but some like it's usually not the case, so you would be able to get mint and burn to track the liquidity, the minted liquidity pool tokens as well, but we don't need it here. So let's continue. What's the name of the contract? Let's call it pool. And where we want to go, mainnet or testnet? I like testnet. And what's the address of the contract? I actually don't remember, so let's copy it from here and paste. Yeah, and an interesting thing what you can notice that in Fuel addresses are longer than in Ethereum. It's a good thing for the future. Yeah, no need to add another contract, and let's keep the API token. It's not required currently. And wait when the initial directory finish building. So it's done, and it says please go to the backend to see the changes, and let's see what's going on here. So this is a like complete framework with TypeScript configured, with some predefined schema Graphql entities, so it and dummy entity for the deposit event and transfer event if we wanted to store them just in a raw format. Some README, you can always go to the documentation if you have any questions. And what's the most, I think, core file of the Envio Indexer is the config.yaml. Let's hide the terminal. And here we have pretty much everything describing as a indexer. So we have a nice autocomplete with this YAML language server. So if we don't know anything, like if you have any questions, we can click somewhere and press Ctrl space to enable the autocomplete, and so we can add some additional fields. Also, it helps with validation. And here we are on Fuel, and network ID 00 is for testnet, and mainnet is 9889, I think. Also, we can choose a star block from which we are going to start indexing data and trying to find the receipts we want to process. I think, let's check which block it is. So this happened at block 14 million, but the Envio is super fast, so let's keep it at 0 just for interest how fast it will traverse all the chain. As the name of the contract pool, our address, we can have multiple addresses. Also we have like factory addresses, for example, if the pool contract is not created like manually as I did, but if it's created by another contract, we can create we can also like dynamically add this, register these addresses by indexing this contract factory. Read the documentation, we have more details there. Pass to ABI and the handler. Also, there is a list of the events we've chosen. If you, for example, want to change your mind and also want to start indexing liquidity pool tokens or some other things, you can add a name here. And for example, if so mint, call, burn. Also, you can add some specific logs here. And if you want to add a new log, go to the ABI and copy this ID and add it here, and then you can start indexing it. So this is after you've created an indexer and use it for some time. And here I have the event handlers, and this is the second interesting file here. And here we actually have handlers which handle events. So whenever a deposit event or better say the deposit event log occurs on the chain, this function is called, and here we can get the data from the chain. For example, we can get the block address, like transaction ID, and also we have params. And in params, we have amount, recipient, and recipient has like bits. Like this is just maybe looks a little bit dirty, but this is how the if we take a look at the event, this is how the identity type is structured, and which is nice that you have types and all the data is decoded, so you don't need to manually do this. So we can either, like, you can also check whether this identity and wallet address or contract ID. Also, you can get the address itself by reading the bits field. So we can do this by like this recipient address, and then we can get the units data, and we can store this in the to our Postgres database using this. Here is pool deposit event entity, a little bit confusing name, but we are going to change it now, and we can store it there. Also, nothing blocks you, like for example in subgraphs, it's like assembly script and super closed. Here we can just do even like fetch something, and like you can do any asynchronous operations, like you're not limited like to anything here. So now we are going to use all of this to actually build the backend, and I think what's worth to show is that we can already run this. Not here. We need to open the backend. That's clear. And we can already run the indexer, and we'll be able to see that it works. So let's take a look. I don't know how much time it will take. It's actually super fast. Skipped all the irrelevant blocks. This is happened because we use hypersync under the hood. It's like really powerful way to get data from EVM or full chain. And yeah, after it's done, it's continuing querying at the head. Like 2 seconds latency, not ideal. We are going to improve it soon, but still quite fast. And you can see that it processed 5 events, and like it took like less than 1 second. No, it's sorry. It's since it can catch to the head, it shows that it's less than 1 second left to finish. But it took like something like a few seconds to get all the data. Usually, if you did it manually, you'd need to query all the like block by block, transaction by transaction, and it would take much more time. So, and what we get, let's take a look at the link. So we use Hasura on top of our Postgres database, and we can use Hasura to see some data. And for some reason it doesn't open, and this is because it also needs some internet probably. So, and here we can either write some queries manually, like for example we want to get all the pool deposit event IDs, and we can get them. This is like a combined ID of the chain, block, and chain, block number, and how to say this? Probably it's receipt index. And also there's a database view. So we can take a look at the tables separately. So, but I think this is not super interesting, and it's much more interesting to look at the actual liquidity pool data and at some weird receipt IDs. So let's start and build this. Okay, I'm back at the ID, and to do this, let's start with designing the data. And for this, we need to go to the GraphQL file. So what data we are going to have? Let's have a pool. Remove this event entity. And for pool, let's have balance. It will use begin, makes sense. Also, we are going to have, let's rewrite it. Okay, balance, I think is good. And let's also have created add. So yeah, and we have time here, time type. Let me think whether we need something else. Probably not. So after this, what we need to do, let's open the terminal. Here we write npm code again, and it will regenerate the types for us. And what's wrong? Okay, it works. For some reason I saw that it's called time, but it's timestamp. And here we can see that after generating the types for the entity, it started complaining. Oh, actually I have a name collision here. So let's go and also change the this to pool contract and regenerate. So now this is a pool contract. Let's change it here. And also we got a pool which became a type. So if we start using the pool for this type and also for setting, it will start complaining that, let's comment this out for now. It will start complaining that pool name is not found, but let's edit. It will start complaining that it misses some field like balance and created add, which is not nice. So what we need to do now, the logic is when we get the event, we need to either create or get the current pool, read the balance, and for the deposit, we need to increase the balance and then save the pool again. So let's try this first. It should be super fast. I want to write get pool, get context here, and I want to get ID. So let's use for the pool, let's use ID as an ID, the contract address. Nice. So, and for context, let's use the handler context here. So from context, what we can do, we can try to get pool. Like this. So we call context, then we choose an entity we want, and we can either delete or get or set it, and here we provide an address for this. Also, it should be async. Yeah, and pool might not exist, so you can see that it's might be undefined. So if there are no pool, need to add parentheses here. We need to create a new one. In a new pool, it's going to be ID address balance 0, which is actually, let's actually add a pool type here so it shows us more info. And what else we had? Created at. And what we are going to use for created at, I think we could use a current time, but it's not really true. So it's better to use the time of the event. Now let's skip it and use current time. And after we created the new pool, let's immediately return it. And also we need to set it to the storage so we can use it later. And yeah, the thing is that created at is not nice. So let's add an argument here and call it event time, and use the event time for the created at, and the type is date. So now we've got this get pool. The type is not good. It should be pool like this, and it complains that we don't handle undefined. Also, it should TypeScript don't help us at all here. How to do this? Okay. I forgot to write return. That was the reason. So we have our getPool function, and let's call it here. And what we need to do, we need to pass context. We need to pass an address of our contract, and also we need to pass the event time. And event time is inside of the event block.time. This is why I said that we should call it time in the GraphQL. And where we are going to get the current contract address, actually have, okay, we can get it from the event, it's source address. And what's the time is actually in seconds here. So we need to, okay, let's do it here. So to save some logic for usability, and wrap it with new date. I think this is nice. So we turn it in milliseconds and then create a date instance. So we've got our pool here, and we just need to modify it a little bit. Actually, I think we can skip this. We don't need to set it because we are going to set it anyways. Still add type here. Okay, it's not possible. You can see that I might do some dumb mistakes because I got used to writing a script. So we have pool, and what's left is to modify the balance, so and set it to the database, to our storage. And let's immediately do this using the set function, so we can spread our existing pool and modify the balance. And we can get the amount from the params. We don't need a recipient here because we don't care. and amount. So that's nice. Amount is begin, balance is begin. They sound pretty well, and it works. And let's do the same for the transfer. It shouldn't take long. So I copy pasted the content of the function, and I've copy pasted actually the whole handler. So we need only the content here, and it doesn't show any errors, but the only thing, like, because we have amount also for the transfer coming by default, even though it's not a log but transfer receipt. Actually, it's transfer off, because transfer off is for wallets. So here we remove, like, we have pool balance minus transfer amount, and this is actually not going to work. I just realized, because what we need to do, we first, transfer, we get transfer for both when we send liquidity pool token and when we send Ethereum. And this is a good use case where I think a lock would be much simpler, because you would be able to put simply, let's take a look at the contract, I think, instead of just me talking. So when we index transfer, we get both this min2, and also we get this function when we send Ethereum back. And we will be able to, like, avoid adding a condition to check which one of them here is if we would add a log, something like withdraw event, and put all the data here. We will be able to simply index this log, but since we don't have this, we can, and maybe in cases you don't have logs, you can, like I showed, that you can use the transfer as well. So what we do here, we need to get the params, and here we have an asset ID. And what's the asset ID? Asset ID is a string, and we are interested in Ethereum transfers. And I remember I had the asset ID here. So let's paste it, and I hope it will work. So if this is an Ethereum transfer, then we are going to remove the amount from the balance. So this is nice, and let's start the indexer and see that it works, and then we'll move to the history, and it's not going to be more changes, much more changes here. Okay, let's wait when it starts. Okay, it's done. So now we have pool, remove this, and pool should have created add ID and balance. And yeah, it works. So we have balance, ID, created add. As I said, like, it's nice to use contract address as an ID, because, for example, usually there are pool, like, factories, and you can dynamically add the contracts instead of listing the address in the config. So this is nice, but not super interesting. Like, we have a built-in entity history, but this is more for internal usage. Actually, it should also be explicitly enabled, and we want to have a more fine tuning and, like, more control. So now we are going to create a pool history entity, which will track the balance at every point of time, like every balance change. We'll be able to store this and then get using this Graphql API. Also, like, don't be worried that I use Graphql here. Asura also supports, like, relay backend. Also, there is REST option, so it's like it's customizable here. So let's go. Yeah, and to do this, let's stop the indexer, close everything not needed. And what do we need to do to add pull history? And this is to start with the data. So let's structure how our data looks like. And let's create a pull history entity. It also should be an ID. Also, we should have a pool, which is a reference to a pool. And also, there's a new thing, index. Since usually, I think most likely you will pull history by a pool address. It makes sense to add an index to this field so the query is more optimized. And also we need balance and time when the change step happened. I think that's all we need. So let's go open the terminal again and write pnpm again. Nice. And let's go back to our handlers. So let's start with the deposit event handler. And here, besides the pool, besides updating the pool entity on the storage, let's also start adding a pool history entity. And the thing is that ID should be unique, and a unique ID for an event is a combination of the transaction ID and of the log index. So let's create a function. Let's get unique ID, and it's going to be we want to get event and event log from here. Let's add the type for this. We don't care about the type, the exact type for the params. So, and here we can combine, let's use normal string, event, transaction ID, and let's add dash, or let's use a column. And also we can add log index. So this is nice, we get unique ID here. So now we need to, let's rename it get unique event index. or even like this, my naming preferences. And here we should also add pool ID. I think it should be underscored. And also I think we have balance, which is, let's move to the variable, new balance. Set the new balance here, and also we are interested in time, and also let's add time here. I don't want to spend time to think how to reuse this. I'm just live coding without spending much time on actually thinking what I'm doing. It's a little bit difficult to process, write the code, speak, and do something meaningful. So I'll do the same here, and I think this is going to be enough. So probably we are done. Let's run pnpm dev, and we're going to see the results. I'm not going to cut this part so you can see how fast it finishes. And remember, we don't have the star blocks. So for example, it would be like, let's cancel this just to showcase. We are somewhere at the 14 million blocks. So if we add a star block, like if you know when your contract is first deployed, you can add a star block, and this is better because you don't need to spend time waiting when we finish indexing all these 14 million blocks. So let's take a look how it will take. Yeah. Nice. Yeah, nice, it works. Not super faster, but it is. And if you have a more complex query, it will be definitely faster than having star block as 0. So it's still recommended. So here now we have, let's instead of querying, just take a look at the raw database structure. We can see that we have 3 rows here, and their balances are 0, 100, and 0, and then 100. So this is interesting, and we could actually just realize that probably it would be interesting to add the diff, how much it changes and like in which direction, but let's not spend time for this anymore. So what you can do do with this now, it's actually super powerful. You can get the run this, and you can think there's somewhere a URL here. Yeah, you can get this Graphql endpoint. You can query all the pull history, get the balance, and also like the query engine is much more powerful than, for example, the SAC graph. For example, you can query like some balances like between some specific period of times. For example, you can get a where time is greater than, yeah, I need to figure out how I should use the time thing because it's timestamp. Let's actually to help me query at least something. Okay, let's remove the filter. Okay, for example, we can get, let's test this. Yeah, and we can get all the pull history starting from this time, or we can get greater than equal, and also we can add ordering, like, and even more complex, like add limits. We want to have only one entity, so super powerful. And after all this, the question is like, we have a working database, we have working GraphQL. How we are going to provide this for our front-end developer so they can use this? Because we can have this local GraphQL endpoint, but it's not nice. We want to be it live somewhere on the internet. And there are 2 ways. The first one, you can self-host it. It's not the simplest way, because there are quite many parts involved, because it's database, it's Hasura, it's also the indexer itself, but it's not like super complicated as running your own node, for example, for a subgraph. You can simply start this like by running the JavaScript file with TS node, and also by providing environment variables to configure Postgres and Hasura. Not simple, but it's possible. And another way, we have a hosted service from us, Envio, and here's our website. And hosted service is the best way, I think, To start, we have a free development tier for you to experiment and already start building, and also a really reasonable production tier pricing. Let's open it and hope that my internet works. So the production small is for $70 per month, and yeah, it's really reasonable price, I think, for what we provide. So you can read more about the pricing and the features in different development, in different tiers, development, production, or even dedicated, with direct access to the database and IP whitelisting. So everything you would theoretically want and need. Also, on our website, there is documentation where you can find even more details about everything I just shown live. And yeah, here we have an Explorer, and you can see that I'm currently on V2, so there are not that many indexers, because we launched V2 exactly today, I think 5 hours ago, and these are some people who already migrated to V1 and started building here. So, and we are going to be one of those people, so you'll see how easy it is to start. After GitHub authentication, you should see your personal page. Here, I already have a lot of GitHub repositories connected, but in your case, you should only see this block saying, please connect a GitHub repository and start indexing with Envio. So after clicking connect, you'll be able to choose either your personal account or organization and select some repositories you want to connect with our Envio application. So every time you push a change to your GitHub repo, we are able to fetch this and start deploying your indexer automatically. I have it's already connected. It's called Sway LP. So let's click Add New Indexer and let's call it full. I don't know why I call it loop. Just my brain already started thinking in reverse after such a long video. So with description, let's keep this field, and indexer directory, this actually we need to adjust, because as you remember, we've put our indexer in the backend directory, and usually we assume that it's in the root of repository. So here we need to write backend, so the hosted service can find our code correctly. Config file, we don't change this, and usually you only need to touch this when you want to, you have one indexer project in a repository, and you want to create multiple indexer services, for example, one for Testnet, another one for mainnet, and you have multiple, you have separate configs for them, and you can choose two config in one repository, so you use some code and you just choose which config you want to use when you create a deployment. And release branch, by default it's Envio, so you only deploy when you push to Envio branch is some sort of release branch for you. But here we'll just keep it as main. I think it's just simple where we have our final changes which are deployed in the main branch. And by default, all the indexers are deployed in the development tier. It's nice for testing, it's free, and it also provides us good speed, build time, indexing time. Also, it provides us a GraphQL endpoint, which we can already start using for building our front end and other applications. Yeah, but I also should note that it's not suitable for production because there are some limitations, and it's not the most stable infrastructure. So after we've chosen everything here, let's click connect. Didn't click this, and yeah, we can see that we don't have any active deployments, and to create a deployment we can simply run the git push. Actually, don't need to copy this because I have my VS Code VS Code UI for this. So I've pushed my changes. Let's go back to the hosted service, and we can see that it automatically updated the interface and shown that we have a deployment which is building. And this is just the first hours of our hosted service v2. So I don't know how much time it will take. Okay, we already have a GraphQL endpoint which we can start to we can send to our front-end developer, for example, and for them to start using it. Also, we have a pro feature that you can make the endpoint static. So when you create a new deployment, you can then switch the endpoint to that another deployment without breaking your front end, which uses this endpoint. And while I was speaking, like when was it? It was deployment 1 minute ago, and we already have a build and indexer which finished its job. So it was historical sync time less than a minute and 15 million blocks. Like, I admit that I have only 5 events, and this is a super simple indexer without any logic, but believe me, it would take, I think, hours if we did it some other way, using not hypersync and hyperindex, but just, for example, GraphQL API of the full node. Yeah, and yeah, also it's rate limited, so it would probably take even more. Yeah, so we are done. It's crazy. What we can do, we can actually verify that we are really done. There is a playground link, so we can open it. There is a GraphQL query, and we can run it and see that it returns us some data. And yeah, it's amazing. Actually, I think it finished running faster than my MacBook, and trust me, we didn't connect a MacBook to our service or something like this. So it's really, yeah, I'm personally actually really surprised. Yeah, I think this is a good point to finish this video tutorial. I don't know how much time it took. For me, it took several days because sometimes I forgot to turn on the screen recording, and now I have to re-record some pieces. But I think this is going to be the most detailed video tutorial about building on full network. Because actually, if you think about this, how much we've done in this few hours, we've discovered a new network which is really recently came to the mainnet stage and is completely new architecture and design, a new Sway language, programming language, which are not many people are currently familiar with, but I think it's going to change soon when Fuel gets more and more adoption. So we've taken this programming language, built a production ready, I would call it, a smart contract. We have a script where we can deploy this smart contract both on testnet and mainnet, have some test interactions with this, so we don't need to manually call them using interface or something like this. We can just run this test script and during the smart contract development and see how it performs. Also, after this, we took it even further. We've created a completely working, flexible backend using the Envio Indexer, and even deployed this. And I think in the second part, this is what I wanted to show you the most, because this is what we are building, but it took even less time than the first part where we built the smart contract. And it's really great how smooth it was, the initial configuration for the indexer, how easy it is to write a schema, to write the handler logic, and also how fast the hosted service is working and how easy it is to connect to your existing GitHub repository. So I'm really amazed about this, and yeah, it might sound a little bit sugar-coated and biased, since I'm a part of the team who built this amazing product, but really have to admit that it's good. Trust me. So yeah, at the end, I think what's worth mentioning is that everything I showed you here, I'll leave links in the description. So I'll leave link to the full website, also the full form. If you have any questions with building a smart contract, the full form is the best place to ask questions. Also the full documentation, I definitely recommend you checking it out, because I've shown you how to build a SWA contract in quite details, but there are still really many things missed. And yeah, about deploying, there is a block explorer, and yeah, it's going to expand soon, as I know. So it's going to be even cooler, and you'll be able to see verified code there. Not possible now, but should be in the future. And then we've taken an Envio Indexer and built the backend for this. It's really amazing. So I also leave links to the Envio website, Envio documentation. And yeah, if you want to walk through the video tutorial and build alongside with me, there is going to be a repo to the GitHub. There's going to be a link to the GitHub repository with all this code, so you'll be able to take a look and get some inspiration from there. Yeah, and definitely if you have some questions about the Envio, definitely recommend you join our Discord channel. And yeah, we are always ready to help. And even if you don't have any questions, just come and say hi. I'll be really happy to see you there.